Hey, hi. This is Priyanka this side, and today I'll be talking about day 9 lead code problem, which is word ladder. And here, if you were with me till last video, then I would like to mention that this is the toughest problem of lead code so far we'll be solving. And so just stay with me and let's try to solve it today. Here we are given two words, begin word and end word, and a dictionary named word list. Here we need to return the length of the shortest transformation sequence from begin word to end word, such that only one letter can be changed at a time and each transformed word must exist in the word list. That means we have to transform begin word to end word, keeping in mind that only one letter can be changed at a time, and all these counts we will be counting along with this. Okay, and whatever change we get, whatever after changing one letter in the string, whatever outcome we get, that must be present in the word list dictionary. Then only we can count it as a valid change. Okay, and here we will return 0 if there is no such transformation sequence. Here, if we talk about this case, here a begin word is hit and end word is cog, and this is the dictionary given here. Uh, okay. So before going through this, we will just have a view over constraints here. Begin word Begin word's length is always between 1 to 100 characters, and end word and begin word length should be same. That is the case where we will be able to solve this, otherwise no. And word for and length of word list strings would be between 1 and 5000. And what does this and this mean? That all the strings that will be countering in a particular use case, all will be having same length. All will be in lower cases, and begin word can never be equal to end word, and all strings are unique in word list. That means we can call it a set if we are given as a set. Actually, they have given us this list, but we'll be soon converting it into hash for our ease of access. And here what's happening? Okay, so what I'll be doing here is I'll be looking for one letter that I can change in this particular word, so that it make a so that whatever outcome would be, it should be present in this particular dictionary. Okay, then only I can count it as a valid change, otherwise it won't be. So as I can see here, h, if I change this I to O, this hit becomes hot, right? So I'll just use pen to describe it a better way. It will become this. Okay, and in this, if I change H to D, it will become dot. And here, as if I change this H to L, it will become lot. Okay, so what we need to track here is count of these changes. Correct. So initially it was 1, because anyhow, if we are given with hit and its end word is hot, then initially it would be 1, and when I'll change this, it will be a 1. It is one kind of a transformation, and then I will change this hit to hot, then it's another kind of transformation that makes it 2. Output would be 2 if begin word is hit and end word is hot. But here it is cog, so we are going to figure out how we will count that. So for now, initially it will be 1. And okay, so this is one transformation, this is second transformation. Okay, And from this, either I can go to dot, or from here, or I can go to lot. Okay, so I can mark it as 3. Now when dot, if in dot, if I change this T to G, then it becomes dog. Then this becomes fourth. And from lot I change T to G, it becomes log. It becomes fourth transformation, correct? Then from dog, if I change this D to C, I'll get cog. This becomes fifth transformation of mine. So there are other possible ways as well. So, but here we need to find the shortest transformation sequence, which is 5. 5 is the count of minimum transformation sequences that will be required to get cog from begin word hit. So, all right. So, from this approach, you can have some idea that we can represent this problem in this problem solution in the form of graph, where all these strings are representing nodes. Nodes, as in every node is connected to some another node in some or the another way. Correct. And there is no one way approach. If it would be, then we would have used tree, but it's a two-way change. It's a two-way connection. Hence we are going to use graph here. So this hit is connected to hot, and this hot is connected to lot, and this hot is connected to dot as well. And or you can say vice versa. Or let me show you another connected way of this. So how it could be? This is one way, it's connected. This is connected one way, and lot is connected to dot. Correct? So there can be many ways, but in order to make sure that we are not visiting a node again and again, so that we don't waste our time, we don't waste memory, and other things, we are going to we are going to also make sure that we are not visiting that again. Okay, so for that case, how we will handle that, you need to be with me for that. Okay, but still I will strongly suggest you guys to um, try to solve it once on your own. Whatever hints I have provided to you till now, try with that. If you don't get the answer, or whatever answer you come up with, then you can add my solution or explanation to it. Okay, so here, very first thing we are going to do is we will have a set of strings. So here, any class you can take, either hash set or set. Previously I took set as it is a interface, it's a class. Hash set is a class. So, and now I'm trying with another variant, which is hash set. And next thing, I'll have a queue. So what I was doing, hit is connected to hot. Okay, so whatever, so I'll keep on adding whatever changes I'll get by just changing one letter in the in this string, right? And I'll add that into my queue and remove that from this list, so that I don't parse it through again. Okay, so here I'll use queue of string. So queue is it's an interface. So Q is an interface, so hence I can't instantiate a interface. That is why I'm going to use class here, which is linked list. And as I'm going to begin with begin word, so I'll add begin word into the queue. Begin word. And this is queue. All right, and at every, I'm also going to keep a check on counts, how many times I'm uh, changing one letter at a time. So for that, I'll level 1. So as I told you, I started C with 1. Its initial value was 1. Here I'm giving level value 1. So in order to explain you better, so this is hit. If I changed I to O, it made it hot. From H, I changed H to D, it made it dot. And here I changed T to G. So these are the levels. You agree with me? So here, this is one level, this is 2, 3, 4. These are the levels. And transformation for level L would be L plus 1. How? So in this case, transformation is 1, 2, 3, 4, 5. So hence its L plus 1 would be the transformation it would require to go from begin word to end word, wherein we will be changing one letter at a time in this string. Now, what happens? I initialize this level with 1 and I'll be going through each and every string that is present in our queue. So, I'll run a while loop where queue is not empty. Until queue is not empty, I'm going to run this loop. And I'll first, so here we saw from hot, I can either go to dot or to lot. So to lot as well, I can go. This is one of the scenario, not all. So for in that case, I don't know. I don't know whether this dot path would be the shortest or this lot would be shortest. So I will be taking both of these one at a time. Okay. So for that only, so in that case, I'll be having dot as well as lot, both of these in my queue at a time, and I'm going to check for both of them. So how will I do it? That in size, I'll take the size of the queue. Okay, and now I will pass through each thing. Okay, now we are now what we are having. This is the size queue. Now I will string, let's call it S equals to q dot remove. So I know for this particular level of the graph, I am having 1 or 2, any size, whatever we are having, I'll remove them one by one. So for an example, we were having dot and lot. Now first I will check with dot. So I removed dot here and saved it in my variable s. Now what happens? Let's say this is dot. Okay. Or let's start with hit first. Okay. We are having hit. At very first time size of the queue is 1. We will run this loop for the one time, and this word what we have got from here is hit, and then I'll change the letters one by one of this string, and then I'll check if that change or transformed word is residing in this dictionary or not. If it is residing, then I'll proceed with it. Otherwise, I'll just crap that out. So if this is hit, then I have to first get access to each character of it. And we know that this string is immutable. I can't get access to its one character to make a change. So basically I can't make a change to its just one character and use that same string again. I can't do that. Hence I have to use a character array to make access of it easier. S dot to var array, right? And then now I will run a loop for this j less than c dot length of this character array. And for that, now how am I going to know that what letter should I be changing with what letter, so that I get something which is present in this word list? How am I going to do this? So here I'm explaining best version and easiest version of the code, so that every one of us can understand it better. And once we get how to resolve it, then later on we can know, later on we it would be helpful for us to optimize it. So that is what I'm going to do here. So checking that I'll be checking that by brute force approach. So what I'm going to do here, through this loop I will have access to each and every letter here. First, I'll check this with this letter. What if I replace this H by A? Then it becomes AIT. Am I having this in the dictionary? No. Then I'll just scrap that out. Then I'll replace this H by B, and then I'll check, am I having BIT in this dictionary? No. Then I'll just again scrap that out. Then so on and so forth. I am not having any any letter possible here that will give me a valid change. Then I'll get access to this second index, first index. If we count it from zeroth, first index character, I'll change it to A, and then I'll check, am I having HAT in the dictionary? No. Then likewise somewhere we will hit O here. So HOT, I'll check if HOT is present here. Yeah, it is. Then I'll proceed with it. So let's see how we are going to do that. So this is to get access to each character in this string, and how am I going to replace that? Let's take K, which will start from A, and K is less than or equal to Z. It will run from A to Z, K plus plus. Okay. Now I will replace this character with my character. Okay. But here it will update my string, right? And I don't want that. So I will, before changing it, I will save it somewhere. So that I will quickly wrap it. So here is temporary character where I'm saving it before changing, and at the end of the loop I will restore that character here. Okay, and here I'm going after this. Uh, as I'm going to first I will convert it into the string because um, new string dot new string C. So I'm going to make use of this string many times. That is why I did this. Now I will check if it is present in the set or not. This S2. What if this is present? What if we came to this cog and this is present here? Our foremost target is to find if we have hit with the end word or not. If we have, then just return level plus 1 as I described you before. So I'll just first check if S2 equals end word. If it does, then return level plus 1. Otherwise, I will add this into queue. I will add this S2 in the queue and remove this from set so that I don't traverse it again and again. S2. Okay. Now, and yeah, I'm also incrementing this level by 1 each time. So what's happening here? Uh, this is the size of the level. At every level, first we'll be counting the size, and then I will traverse through each node which is present in that particular level. And as soon as we complete this, as soon as we complete this loop, we will get out of one level. Hence, after that, I'll be counting it as another level so that we can get this count correct here. Okay, now let's just go through it once. Level. I'm traversing through each node here. Through each node through the level. Then I will grab the string, convert it into character. Then I'll try to change each character in the string. Then I'll check if it is present in the dictionary or not, and if it matches with the end character, I'll just return this. Otherwise, I will add it into the queue so that next time we can check that, and we will remove from set. I've already explained that. We will restore it, and we are returning integer. Hence, we need to return something from here. If all these things doesn't happen, then there was no level in the graph, we can say. Hence, we will be returning 0. Okay, there is a typo. Again a typo. Or Q. So where are we having this Q? I think we are good to go. Remove. So it's a function. Remove is a function, not a property. It's 0, so what's wrong here? So I just forgot to put this into set actually. This is an empty set here. And we also need to make a check if set contains this end word, then only we will be proceeding. Otherwise, we will just return 0. If it doesn't contain, so what happens here? We are looking for cog. It is not present in the dictionary. Then there is no way we can get this cog as it is not present in the dictionary. Hence, we will be returning 0 if when we don't find this uh, end word in a set. Okay, so it's working fine for this particular use case. Okay, done. Okay, then thank you guys. Thank you for being here with me, and please like, share, and subscribe my channel for new videos that are coming up. Thank you so much.